Hello everyone. So we're going to work on the topics for exam 2. These are going to be mainly regression, simple regression model, simple regression model, and we also want to work on diagnostics, which is in fact your regression assumptions. Okay, so let's double this. Okay, so when you want to start doing analysis on simple regression model, or specifically, you can say exploring relationship between two continuous variables, right? So that's the main goal. We use simple regression model. So the starting point for us is going to be checking. Number one will be, we want to see if there is a linear relation here. Right? Linearity is the first thing we check. So on linearity, what do we use? We use scatter plot. And to graph a scatter plot, we can use the fit y by x. And here, let's say you're a manager, you have this data given to you. And of course, as a manager, what's important to you for business is to have higher sales. So we can decide that sales is a response variable. So let's have sales response variable sales, and let's say let's use the other one. Let's say income of your customers, right? So let's have income as a explanatory variable. Explanatory variable. Okay. Let's have this be here. So I go to fit y by x, and let's this time use the fit model. It will give you exactly the same answers, but it has more flexibility when you're getting answers. Okay, it's the same thing. It's just can be used for more independent or explanatory variables. So let's have sales as your response in the y, and let's have income inside the construct model thing. So that's where your explanatory variables, IVs, go. This is where your response variables go, right? And so we want to create a scatter plot. So let's see, let's do a minimal report first, minimal report. And standard least square is the regression model that we're using. Click run. Look, this is the same as what you had in fit y by x, right? So you have the scatter plot, you have the values of income versus sale on the scatter plot. You have the regression line. What else do we have? We have the R square. We have the adjusted R square. We have the errors, standard error, 74.8. Let's see what else we have. We have the primary estimates. We have the intercept, 97.07 plus 6.4 times the income. So you can see that they are not both significant, right? So let's say that they were significant. So what is the next step to do? Next step, you want to see that regression line. So I believe you can click here, go to estimates, and click on the show prediction expression. So if you click on show prediction expression, what's going to give you is the equation of the regression line. So we click, and down there at the end, that's right here. Of course, the sales on the left-hand side is not shown, but the sale equal to 97, intercept plus 6.46. So let's see if we do this with the fit y by x, we get the same numbers. Sales, income, click OK. Right? That's the same solution here. But we don't have the line here. We can add it, fit line. That's the fit line. That's the same graph. Okay, and that's your equation here. That's your R square. We can also add the, let me see, we can add the summary up here and see the correlation value, 0.7. Correlation R, Pearson correlation R. Is it significant? Yes. R squared 0.5. So you multiply 0.7 by 2 by itself, or square it. A square of 0.7 is 0.5. And then we have the same numbers down here. Okay. So what else do we do? So that was linearity. Does this shape look linear? The answer is yes. So we have linearity of the relation. Now we need to go and check the rest of conditions. So we report the correlation value, correlation R, small r equals to. So in the question, the system will ask you, what is Pearson correlation R? And I just showed you how to find it, right? On the fit y by x, it's, you click on that red triangle on the top, click on summary statistics. It's going to give you the R value. Same thing goes with fit model as well. Okay, so then and correlation R, and then you need to interpret it, right? So it was 0.7, 0.7, and that's a strong relation. And then R square. What is R square? R square is 0.5. What do we learn from R square? Of course, on exams, you're always being given the information of how many decimals to round to. Just pay attention. I'm using 1 decimal right now, but if you had more, you can use more. So you just multiply this number by 100 with the percent, and then interpret it, right? So we have 50 approximately, right? 50% of the variation in sales is explained by the variation in this case was income, right? Income. Okay. So we're exploring the relation between two continuous variables. One was the explanatory variable sales. Let me highlight this. And your explanatory variable is income. Let's put this down here. Okay. So these two were given to you. Some question will tell you exactly which one is explanatory and which one is response. Some questions won't tell you, okay? If they don't tell you, the question will somehow show you which variable you want to control. Sales is something that you want to control. Efficiency, price, profit, These are the things that you want to control. So these are normally in any business, whatever you want to control it, you want to improve it, or if it's cost, you want to reduce it. Those are going to be your response variable, if the question has not mentioned anything about it. So that's how you explain the R-square, okay? Multiply by 100% and say that amount of variation in your response variable. It's always response. So response, if you don't remember which one to use, remember that it's a response. It's explained by explanatory variable income. Okay, what's next? Next, let's just type in the regression formula. So we have the R square, and what is the standard error? Standard error, SE, equals to, it's right here, square error, 74.8, 74.8 is your standard error. And I hope you remember what the standard error is. Standard error is standard deviation of your errors, your residuals. So you need to remember that. Okay, then next one we look at number of observations, n equals to 65 here. It's right there. We use 65 samples to get these solutions. And the equation is regression equation or regression model, right? You can say regression model is sales equals to, and let's round these numbers, 97.1, 97.1 plus, and then we have income, 6.4, 6.46, let's say 6.5 times income. That's your regression model. So most of the time in questions, there will be a empty space. You just fill up the numbers, but make sure, check the rounding required by the question. Okay, so there are other things that we need to check. The next step is, so we checked the linearity, right? We checked the linearity. We checked the correlation R, checked the R square. We found the standard error. Compared to the 97, it's smaller, and you can see the variation changes of around each value for income. It's not much different. It's almost the same all over the different values of income. So that's a regression model. And then, so how do we interpret this regression model? For every, so income is in 1,000, right? So every 1,000 unit increase in income of our customers, how much more sales do we have? In average, right? In average, we have 6.5 more sales. Now, our sales in this specific case is in dollars per square foot. So dollar per square foot sale will increase by 6.5 for every $1,000 that our customers have increased in their income. All right, next is check the let's check the, so this is a fit model, okay? This is the fit model. Let's check the parameter estimates. Let's check the confidence intervals. So there are three different types of confidence intervals you need to calculate. So we type here, next is number 1, number 2, number 3, So this is number 4, regression model. And then next will be the confidence intervals. So the first confidence interval we check can be the B0 or beta 0. And B0 means the intercept, right? Number will be A. Confidence interval CI for intercept. And then we can do this for CI for the slope. So this is B1 or this is B0 or intercept. This one is B1 or slope or beta 1. B1. We also call it beta 1. And then we also have this CI for prediction formula. And which is for sales, right? Which is for this equation here for sales. So we have for intercept, confidence interval for intercept. We have confidence interval for slope. We also have confidence interval for sales values. Let's go one by one. So for these two, for intercept and for the slope, right here under parameter estimates, you right click, go to columns and click on the lower 95 and click on the upper 95. These are lower and upper confidence intervals, right? So there might be questions on that, and you need to find these numbers. You don't need to calculate it manually yourself. It just is easily being calculated, right? But how are they calculated actually? They're actually calculated based on this number, 97, and then plus minus approximately 2 times of the standard error to the right and to the left of 97. Okay, to the right and to the left of 97. And same here, 6.4 plus minus approximately 2 times of 0.8. So 6.4 plus minus 2 times of 0.8, 4.8 and 8.8. What else do we need here? So we did this too, right? So it's B0 plus minus 2 times of standard error of B0. And this one is B1 plus or minus 2 times of standard error of B1. And for prediction formula, the formula is a little bit more complex. Yeah, so these are, again, there's 3 confidence intervals, right? One is for intercept, let me just bold it. One is for the slope. And one is for the prediction formula. So these are different. And where do you get it? Under parameter estimate, right click, columns, and check the lower 95 and upper 95. Lower and upper 95. So those are actually, manually you can calculate it this way. Standard error of B0 is here. Standard error of income is here. Of slope is here. And then multiply by 2 plus minus the estimate value. Okay, so again, so CI for prediction formula is just a little different. Let's see, we have it here. So you need to have the actual data. Let me see if we have, yeah, we have the actual data. So let's open it and see when we save them, they're going to be added at the end of our data sets. Okay. So let's put them back here and just give some space. Okay. So we click on rectangle and go to Save Columns. Go to rectangle, Save Columns, and find the, so look what we have. We have prediction formula, right? That's your sales. Sales values based on the regression model. This is a regression model. So what the computer does, it substitute values into income and give you values for sales based on this formula, not based on the actual values. That's why we call it prediction formula. It's prediction formula because it's using the regression formula to calculate sales based on different values of income. So if I click here, look, at the end of the right-hand side of my data set, the prediction formula values are calculated right there and down to the end. But these values are dependent on, these are sales, right? Sales is dependent on income. So I have to give values for income, so the formula calculates the prediction formula for the specific new given of. So this is like if we have Xnew, then what is the Ynew? And I hope you have seen that in the book and in the slides. We had Xnew, Ynew. That's where you find. So let's say income, you are given a new value for income, and the question is asking you to find the prediction value. So let's say the question says for 70 we already have. Let's say for 67. If 67 is given down here, I'm typing, I'm adding this number under income because that's my explanatory variable. Press enter and look, 530.05. That is Ynew, Xnew, and then Ynew using that prediction formula. Where did I get it from? One more time. I went to the red triangle, save columns, and prediction formula, right? There are other things we can actually check here. So you can also add the...
Can you say that again, Professor, how you did that?
Yeah, sure. Sure. Give me 1 second. So we go here, save columns, prediction formula. It's going to add the prediction formula at the end. And then let's say the question on your homework or exam says, for a new value of X, what's the sales value? So you just click here, put any number is given to you. Let's say it's 100. You can see that the sales for a person who earns $100,000, the sales, I mean, this is estimation, right? Estimation in average for a person who earns $100,000, in average, you can expect to have sales around $743 per square foot. Okay. And then what else can we check? Let me see. Okay, give me 1 second here. All right, so there are two types of confidence interval we can plot around the regression line. And let me really quick show you where to get them. So click on the fit y by x and get your y and x values and click OK. So we have our fit model or fit line. And so if you want to graph that curve, it's right next to linear fit. And you just need to let the curve fit of confidence. This one is when your standard error changes when your x values change. So you can see that the more the higher the value of x, the higher the distance of standard error. 2 times, this is 2 times standard error. This standard error keeps changing. And if you want to look at the formulas, this is the formula. This is the slide in chapter 21, slide number 38. It's also available in the book and is explained very well. So when a new x value is given, the distance from x bar, the higher the value of distance from x bar, which is the average of income, we can see that that distance, that confidence level grows, right? Because that fraction is growing. When that fraction grows, the standard error of the y is growing. This is y-axis, so in y it's growing, and 2 times of it will also grow the same way, right? Approximately 2 times. The t-value will be approximately 2 times for 95% confidence level. And this is, it's changing, right? Standard error is changing here because it's individually for each new x value, this is actually changing. But when we want to see a constant one, let's see, the standard error for this model, this is the model, standard error for this model is 74.8, right? So if we use that standard error, instead of variable, we use a constant standard error, that will give you the constant confidence interval, which is this one. So this is using 2 times, approximately 2 times of this standard error. So, okay, and it's good to know that. Finding the confidence intervals on fit y by x is also the same column, lower and upper for the B0 intercept and the slope. So let's see what else we can find here. So we have these confidence intervals. We have already saved the prediction formula here. So right now we don't need these confidence intervals. We delete them so we can add more important ones. And then if the vertical or prediction confidence interval is asked, is this one. How do we calculate that? So we already calculated for a given value, let's say 100 is given to us, $100,000 is given to us. We calculate a new value for it, right? 743. Depends on how many samples we have. Of course, this can be different, but you just want to plus minus 743.32 plus minus 2 times the standard error of the model. Standard error of the model is 74.8. So 2 times 74.8 approximately, added and subtracted from 743.3, that would give you upper and lower bound of, so let me write it here really quick. So that would be prediction formula value plus or minus 2 times standard error. Not the standard error of B0, not the standard error of B1, the standard error of the model, okay? And we say where SE is the standard error of the model, okay? Not for B0 and not for B1, just plus minus 2 times of that. It's not exactly two times, it's approximately 2 times, because you actually need to find a t-value from the table. And remember I showed you where to get the t-value. So depends on the sample size, depend on the type of problem we're solving, can be a different t-value. Okay, so next one is checking. So let me write here. Next is number 5, check assumptions. What are the assumptions? of residuals. So we want residuals to be normally distributed. We want them to be independent, and we want them to be have similar variances, right? Where do we check these? So there are different ways we can check these values. Let's go over that. And before I forget, let me add here, we can also have number 6, outliers, and I think that's it. Okay. So normality, independence, and singular variances. So this is our results. From these results, we can click here. You see here row diagnostics. So most of those solutions we're looking for are here. So for fit y by x, or for when you have one response and one explanatory, we can simply just use residual by row, and that would be enough for checking a lot of things here. Down here, look, from left to right, the changes vertically is not changing that much, approximately smoothly moving. What would be a big change where somewhere on the left you have very close values, on the right hand side you have a big gap. But here they're almost, the range is almost the same all over the values of income. So we don't have that much variation here. So do we have similar variances based on these? The answer is yes. We have similar variances. And independence, are they independent? So last time I taught you, you learned for, so let's just expand this and let's go down and expand this. Let's do separately for normality. For normality, we can use the quantile plot. There are other methods that I will teach you next time when we move forward to chapter 23 and 24. But right now we can use quantile plot, and that would be enough. So quantile plot, where do we get the quantile plot? So to get a quantile plot, first we need to go here. Row diagnostics should be, do you see here, plot residuals by normal quantile. And we have, that's a normal quantile plot right there. So what do we expect? We expect these points to be approximately on that line, the center. If they're not, at least we want to see them to be between the upper and lower bound here, that confidence level. Are they in that range? The answer is yes. Almost all of them. If they are close to the border, we can expand this and see. Yeah, they are very close actually. Okay. So, so normality is quantified. Make sure that errors are in range between upper and lower bound. And then for independence. So what do we use? We can use rerun this, analyze. So we are using the fit model. So we use red triangle, row diagnostics, Durbin Watson test. And that's down here. You don't see the p-value here. The best is to use the p-value, okay? What is the D? So D, you can type D should be close to value of 2 to be independent, or p-value greater than or equal to 0.05. Let's look at the p-value here. Red triangle, significant p-value. Is that greater than 0.05? Yes, it's greater than 0.05. is larger than 0.05. As a result, we have independent residuals. Independent residuals. Okay, so that's where you get the Durbin Watson. So we learned normality, independence, and the last one is similar variances or homoscedastic residuals. Homoscedastic residuals means, we'll put a dash here, dash, 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 and then homoscedastic residuals. And what we mean is similar variances. Remember, if residuals are not having similar variances, we're going to call them heteroscedastic. If they have similar variances, we call them homoscedastic. And where do we check that? Of course, we check that from the plots of residuals. So, row diagnostics, plot residuals by row. We can see that from left to right. Approximately, we can say that the range of values are not changing that much, right? You don't see that kind of pattern here, right? So, check the plots. Check residual plots by X values. Right, and then last one will be the outliers. So for outliers, I taught you a few methods to do it. Fit Y by X, sales, income, click OK. They both give you the same answers, but some of those options are available under the fit model, okay? But some are available under fit Y by X. So fit line, the red triangle. Let's look at the curve, not this one. We want this curve, right? So where are our outliers? Based on the 95%. This is one way to find outliers. One is here and one is there. And to know which row to exclude, bring your cursor here. Row number 33 is one of the largest. And down here we have row 51 is low. It's actually a little outside the range. Check that, it's a little outside. Even if it's on the border, we can consider it a little, okay? Then other method to find the outliers is to go to analyze, multivariate methods, multivariate, go to analyze, multivariate methods, multivariate, and check your explanatory and your response variables. They both go to Y columns, click OK, and these are your correlation matrix. So that's the correlation, that's the relation, right? You go here on top, the red triangle. Down here, you have outlier analysis, and outlier analysis is going to give you a border line that any point after that border line is going to be considered as outlier. So click on Mahalanobis test or Mahal test. We can also use the jackknife distances. That's almost the same method. They have different formulas, but I checked. They normally 99% of times they recognize the same cases as outliers. So I recommend Mahal because it's very sensitive to sample size, so it's actually very flexible for different sample size. Okay, so we have that is your Mahal distance. You can see that's your upper control limit, 2.4. Any value higher than that line can be considered as an outlier. So I add here, we can use Mahalanobis test, or you can use, you can also use the confidence curve individual, or may depend on the question. Okay. All right, so let's close this one. Let's see what else is left here. Model. So in general, at the end of the day, is this model a significant model as a simple regression model? Is this model significant, and how do we answer that? Is the model significant? Is it reliable? Okay, so since p-value of the intercept is not less than 0.05, the model is not significant, and it's not reliable. We may remove outliers to see if the model become reliable, or another reason could be we could have a lurking variable, or there is probability of existence of a lurking variable. And last time we taught that what the lurking variable is. So lurking variable is a variable that can actually affect on both states and income, right? Or influenced by income and have influence on states. And if you look at your data set, actually, we might have another variable here as competitor. So the higher the income of your customers, the more competitors will join that area to sell to those customers, right? So more competitors means that your customers are going to be divided between you and your competitors. So competitors are also important in creating sales. And that could be a lurking variable. And we can check that just by adding it. You will learn about that in the next few sessions next time we meet. Okay.